We're live with 5 minutes to go, and we're doing our usual sharing. We're going to be doing weights. So today, if you haven't already, oh, the sun just went out. I was relying on the sun for my light. There we go. If you haven't already, if you didn't watch the preparation, I have a bucket full of things to weigh here. Actually, I'm going to add my water to that. And we're going to, I've got an egg, I've got some things from the kitchen, just things that don't weigh much. Sorry, I'm over here. Things that don't weigh much, things that weigh a lot, just different things. I've got my kitchen, not my kitchen scales, I've got my people scales to weigh people, the bathroom scales. I don't have kitchen scales, so I have a little bit of I've had to improvise a way of weighing and comparing weights. And I've got two bags, shopping bags, and a ladle from the kitchen, something that's long, some kind of rod. I could have got a wooden spoon, maybe a wooden spoon, 2 bags. And if you've got a kitchen scale, then bring the kitchen scale. Okay, so I'm just sharing with everyone. I've got 4 minutes till we go live. That's just preparation. Go and get those things. Just go and get things from all around the house that you can weigh. And if you can get your bathroom scales, if you've got them, then prepare, let everybody know you're going to be weighing them, and we're going to be doing some weighing activities. Right, so let me just see where I am. That's me. Okay. So now to share that. There we go. 3 minutes to go. Finish sharing. Go and get lots of things you want to weigh, because this is all about weighing things and finding out how much they weigh. Share to a page, talking and clicking. So, you know, in a year's time, I'm going to be really good at this, aren't I? I'm going to be going, oh, actually, in a year's time, I'll have a producer and I won't even have to think about what buttons to click. So, saying something about this. Weigh everything you can think of. Weigh everything you can think of. There you go. That's that one. Maybe I'll copy that so I don't have to type it in for the next one. Post. Right. That's now on the Bubbly Maths page. So please do like the Bubbly Maths page if you like it. And we're on the Making Maths Fun for Kids of all ages here. So I want to go there. Right, I'm open another page. Making Maths Fun for Kids of all ages. Let me see if I can get this up. It doesn't always work, so I don't always succeed. 2 minutes to go. 2 minutes till we're live. 2 minutes till we're live. And 2 minutes till we're live. Wait a minute. Brain. What am I doing there? I'm going for the group. I'm going to have a look at the group. And I'll look at the other one here, Making Maths Fun for Kids of all ages. Pull that one up there. And pull that one up here too. Facebook.com. No, I'm not going to search on Google for Making Maths Fun for Kids of all ages. Although it would be great if it came up. Maths Fun. Go on, there you go. That's it. You can do it. You can do it. Got that one there. Play that one. You can do it. Oh, there we go. Don't need that. Giving myself a pep talk. Right, now just play that. That's it. We want to play. Oh yes, and this is the one where it's disappeared. We've got, oh, it's 9 o'clock. Time to start. Time to start and get that one going. And this one is not giving me the option to make a watch party. Will this give me the option of making a watch party? If it doesn't, that's it, we're starting. It doesn't matter if we don't. No option to make a watch party, that's fine. That's playing on the bubbly maths, that's playing on making maths fun. Yes, it is. And I can see comments and we're going. We're off. So welcome. Today, it's all about weighing things. We're going to weigh lots and lots of things. Now, we've got loads of activities in today's sheet. The link is in the announcements above. And I'll also put it down on the description below after we've finished. But what we've got is there's lots and lots and lots of activities. So for the next few minutes, we're just going to find out all the different things we can do. And then it's up to you. You can have a look at the resource and then you can choose the ones you want to do. Okay. And you can play along with me with some of them. So it's all about, so the first thing you can do is just, if you just take a minute and run around the house and find things that you're going to weigh, that we're going to weigh. If you can find a set of kitchen scales, then bring them. If you can find bathroom scales, then bring them. And it's okay if you don't. It's okay if you don't find them, that's fine. I've got a bucket full of bits and bobs here. You go, I'll task you. I'm going to pause for a few minutes where you go and do that. And I'm just going to keep, I'm not going to pause. I'm going to keep talking about other things while you go and do that. That's fine. For those people that aren't going to run off and get things, and if you're on the replay, then just pause. And unpause, and here we are again. Okay, so the things I've got in my bucket, I've got an egg. I did take that, that's on the resource. I thought, oh, that sounds like fun. I'm gonna get an egg. Oh dear, I hope it stays in one piece. I've got my balloon pump, because that's something that's very important to me. I've got my water bottle. It's not full, it's not empty. Wonder how much it weighs. I've got a full can of beans, so I know how much that weighs. Does it have, actually, does it have the net weight, drained weight? Doesn't actually have the weight of the can. So when you have a parcel that arrives, like in a shipping parcel, you will see it's got two weights. One is the net weight and one is the gross weight. The gross weight is the weight that includes the packaging. The net weight is the weight of what's inside. So this isn't going to be exactly whatever the weight is on there, which we'll find out in a minute. I got, I wonder how full that is. Is it half full? Is it a third full? And then how is that going to compare? We've got milliliters there, not weight. What am I going to do with that? And oh, got some spices. Now these aren't, I don't have any full packets of spices. If I did, it would help a bit, but it gives me an approximate amount. And I've got this, I do have, and this is going to be very close to its actual weight because the packaging it's in is plastic, but nevertheless, the weight is not going to be, what is the weight on here? Oh, I found it, not saying. And then I've got this. Again, the weight of the packaging is much more than the weight of the product, but it's not full. So I'm not going to have any exact weights here because I don't even have a set of kitchen scales. The only thing I can weigh accurately is anything I can weigh on the bathroom scales. And even then, bathroom scales should be on a smooth surface and I've only got carpet. So there you go. We've got, have you all brought something back? Okay, so there's lots and lots of activities. It's not about doing them all. It's about choosing the ones you want to do. At 10 o'clock in 56 minutes, I'll be doing an activity specifically for younger learners. So early years from age 4 to 6. And so come and join us again there if you've got any littlies in the house, or people that would enjoy activities that are suitable to 4 to 6 year olds. That includes me most of the time. I really enjoy working and doing things that are that trigger the imagination of young children. And then for older learners, in a minute, we'll be doing some other different things. So that'll help you with your schoolwork. And these are activities that you can do that will help you with your schoolwork. So, right, so the little children I'll do later, so if you're upper primary, so if you're about 7 to 11, this is for you. Now, how heavy? So some of you will already know about kilos. So let me see what a kilo is. A kilo is, if this were full of water, this would weigh a kilo. A magical thing about water, and it's not a coincidence, is that 1 litre of water weighs 1 kilo. It's not a coincidence. It was by design. That's how they determined how much a kilo weighs. Now, so this, if it were full, would be 1 kilo. Maybe I should fill it. Maybe I should just drink a little bit from it. I'm not very scientific, am I? That is so good. Right, so this weighs a kilo. So this is our measure. This is where everything starts and ends. Everything's either more than a kilo or less than a kilo. I'm going to pretend this weighs a kilo because it's doesn't. This container is very light, and if it's full of water, well, nearly full of water, it will weigh a kilo. Actually, I couldn't weigh that. I wonder how accurate my bathroom scales are. Let's see. Make sure you can see what I'm about to do. I've moved my Seymour. Let's have a look. Bring this over here. Ooh. Bring this over here. Oh, I hadn't thought of doing that before. I keep thinking of new things to do. Every time I do a live, I think of something new. Let's have a look. Can you see that? Can you see that? Can you see that? There we go. So we'll activate it. There we are. Now, let's see if it will weigh 1 kilo and how much does this weigh? Ooh, oh dear. It didn't like that very much, did it? No, that might not weigh quite enough for it to actually. No, it doesn't like it. It doesn't actually know there's anything on there. So we can't use that to weigh a kilo. If you had a mechanical one, this is an electronic one, so if you had a mechanical one, then you would be able to see it, but you wouldn't have very much accuracy. You might be able to see if it moves to a kilo. But clearly mine weighs about half a kilo, and then it went, oh, you're just resetting me. You're just messing with my head, so it decided it wasn't going to remember that. So fine. Actually, wait. Let's see if we can. Wait. I'm not giving up yet. Whoops. Oh no. No. Is it going to work? Oh no. Okay. So we no longer have our. This is my little device, and it's not going to work. I have to stop the live in order to make it work. I don't think I can actually change that. So, oh well, what happens is it came out of its little contraption, so that's fine. You've seen the scales, and I'm going to now that you've seen the scales, I'm going to just have another go at that. And I can't lift it up for you to see, so I'm going to disappear off camera for a minute. Hello, ready. There we go. I'm going to put both of these on and see if it'll register. No, not even a kilo, but they did go up to a kilo. So this and this together weigh a kilo. It did tell me just for a moment, and then it went bloop, and it went back to sleep again. That's my bathroom scales. Doesn't like weighing 1 kilo. But this and this together weigh a kilo. This weighs 500 grams. Now, why did I say 500 grams? Are we talking about kilos? This weighs, how much of a kilo is 500 grams? How many grams are there in a kilo? Well, I'll just say there's 1,000 grams in a kilo. So this together, these two weigh 1,000 grams or 1 kilo. So, and this weighs 500 grams, it says so. And we did find out that this, just for a moment, this said half a kilo when it was on the scale. So half a kilo plus half a kilo makes 1 kilo. So we now have two measures. They're both the same. But together, we can measure a kilo. Okay, so that's that. All right, we've just dealt with a little bit like that. And now what we're going to do is look at everything I've got in my bucket. Now, I've had everything set up for the other viewer. So now I've got to move everything around and move my computer around so that we can see all the things that I've got we supposedly have lined up. Let's see, we don't want the viewer because that's not working because I unplugged it by mistake. Whoops, there's my cup of tea. Right, can you see the end of the table? More or less. Okay, now what have I got? I've got this, which we know how much it weighs because we've just weighed it. I've got this. I've got this. I've got my pump. Can you see everything? So let me see if I can shine this light on here because the sun's out again now. Does that make it any better? I've got some spices. Got some more spices, and I've got, oh boy, I do like to live dangerously. I've got an egg. Now I've also got a pencil, and in the picture, in the resource, there's a picture of a baby as well. So what would be about the same weight as a baby? Let me see. How about what do you think? What if you look around your room? I'm looking around my room. See something that's about the same weight as a baby. And I just found something. I'm going to put a bunch of books in it. And that's a new baby. I'm going to put this here. That's going to be more or less the weight of a baby. I can't see that too well. Let's close this all up. Whoopsie. There we are. There's my baby. It's quite a big baby. So the baby would actually be smaller than this, but it's going to weigh about the same as a baby. Right. So which one's going to be heaviest, do you think, of all these things? Do you think maybe the baby might be heaviest? Let's see if I can maybe shine some light using my phone. Is that going to help? You've got the sun behind, which isn't helping. Okay, well, right. So we're going to say the baby's the heaviest. Well, I'm saying the baby's the heaviest. And let's see if we can block this off a little bit so that you can see. So this baby's the heaviest. That's what we're saying on the list. Block this off. Block that off. Around here a little bit. How heavy are you? You're quite heavy. You can hold that. There we go. Is that any better? Can you see better? Not very better. Not very much better. This is not a very good camera. Right. Well, we've got them lined up. We've got to line them up in order of weight. So I've got a pencil. I've got a can of beans. So we're going to estimate. I'm just feeling them. I think maybe the can of beans might be heavier. Not sure than the water. Let's see, water. I think the water's heavier than this. I think this is lighter than the water. I wonder which is heavier, the egg or the pump. The egg feels heavier, so we'll put that there. And then the pencil's super light. Now, which is heavier, the pencil? Oh, I'm not sure. Which is heavier, the spices or the pencil? And then which spice is heavier? Is it this one or this one? Again, I'm not sure. I might just put it like that. So they're now all lined up in order of what I think they might be weight-wise, but it's all quite, it's a bit of guesswork. So what I'm going to now move this around because you can't see very well at all with that light. Now the sun's gone out, the sun's gone down again. The other camera is so much better. No open questions, that's fine. Not looking for questions. We're just looking to be able to see the screen. There you go. Right, let me see if there are any questions. And then we're going to have a look at, now if you've got kitchen scales, great. You just weigh them on the kitchen scale. So first of all, you decide what order they should go in and then weigh them, and you can write down their weights. And what you can do is from the kitchen scales, you can, if you don't already know, that's a great way to learn about grams and kilograms. And there are 1,000 grams in every kilogram. So by doing the exercise, you can become super familiar with that. Now, let me just see. I'm just looking to see if there are any comments or questions on the, nothing yet. Okay, on the lives. Cool. So now, I did say I don't have any kitchen scales. So I'm going to, I have improvised. Now you might come up with a better idea than I've come up with, but I've improvised a set of scales. Now I don't know how it's going to work out. It's all a bit bonkers, but I've improvised a set of scales. Are you ready? I have a ladle. A wooden spoon would have done as well, but I found a ladle. I liked it because I can balance it on my finger. So it needs to be something that you can balance. So if you have a wooden spoon, do you see how this has got a flat underneath? It's flat. So I can balance it on my finger. Now, having said that, I've just realized there is a flaw to my, no, there's a big flaw to this. It has to actually be the same length on both sides. That's not going to work. That's not going to work. It has to be the same length. I wonder, that's not going to be strong enough. Ruler. Ooh, I've got me a ruler. So balancing that in the middle, it's a bit of a balancing act, but balancing it in the middle shows us, there we go. So it weighs the same on this side as it does on this side. I have to bring it a bit further away so you can see. Now this is going to be, it's going to be tough. So you could actually now that you know where it is, you can actually hang it off of something, which would be a lot easier than balancing it. Actually, come to think of it, yes, you can get anything as long as you're hanging it off of something, it's fine. But I'm going to do it the dangerous way. I'm going to hang it on my finger. And what I've got, you can come up with something much, much better than this. I've got 2 bags. Now these 2 bags might not weigh exactly the same thing. I'm going to put one bag on one end because I can put things in it. And I'm going to put one bag, this other bag on the other end because I can put things in that. Whoopsie. And let's see if they weigh the same. First of all, I suspect they don't weigh the same, so I'm going to have to move my finger. So that's heavier, so I'm going to have to move my finger over. Now they're balancing there. Now I can put things in and see if I can find 2 things that weigh the same. So I thought perhaps these 2 might weigh the same. Let's find out. Oh my goodness, why do I get myself into these scrapes? Why, oh why do I get myself into these scrapes? Let's see if indeed these 2, it was there, and I can see with the great thing with this, I can actually see how many centimeters I've had to move. Oh, 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 okay, that's okay. I was there, and now it looks like the spice bag weighs more than, oh, the balance. Oh, not quite, it moved. It actually moved. So if you tape them into place, that would also help so they can't actually move. At what point are they balanced? I'm not quite sure how scientific this is, but you can see if one were a lot, that was about where I had it balanced just with the bags. So it looks like they do weigh more or less the same. And you can feel that just by holding them as well. Although something that's small sometimes feels a lot heavier than it is. So let's see, I'm now going to put this egg feels a lot heavier than the spices. I'm going to put that in there without breaking the egg. Let's see. So my finger was there. I'm going to put my finger back there and let's see. Ooh, oh dear. There's an egg in there. It is raw. Oh, look at that. The egg is significantly heavier than the spices. Now to determine, so it was, the egg is a lot heavier than this. Now this is not full. So I do have something, let me just see if that was imagining things. I did have something that was 100 grams. What was it? Okay, here we go. I'm going to put that on there again. See if that's a lot heavier than this. Yeah, it is a lot heavier. So you would have to find something that you knew the weight of. So there's lots and lots of things in the kitchen that you can find the weight of. But that egg is heavier than the spices. I suppose there's a lot of H2O in there. There's a lot of liquid in there. So that would make sense. I'm now going to put it. Found another use for a toilet roll. I'm finding all the uses for a toilet roll. Keep your egg from rolling off the table. There we go. 101 uses for a toilet roll. Should make a blog about it. Okay, so I've got a lovely, lovely scented spices. Lovely. And my bag smells all spicy. Okay, so that's a few bits and bobs to do. I've got my corn here. And now, I don't know if you noticed, but I used the word mass and weight. So what were we doing? We were weighing things, and I might have actually been using the wrong word. I've just realized, because we are in the habit of saying this weighs this, and this weighs that. This weighs 500 grams. Well, it might weigh 500 grams, but its mass is 500 grams. So what is the difference between saying what it weighs and saying what its mass is? Well, when we're on planet Earth, we've actually determined by definition the mass of this object, and we've determined it according to the gravity, the force of the gravity that works upon this weight. So on planet Earth, we've said, right, this has one mass, and its mass is 500 grams. Now, no matter where we take this now, by definition, the mass of this is 500 grams. Its weight is determined by the pull of gravity. So if we now take this bag of corn to a place that has a different gravity, like the moon, then its weight will be different because the pull of gravity will be different, but its mass will still be the same, still the same bag of corn. My mass would remain the same, even if I'm on the moon. But when I step on the scales, the weight will be very different because the amount of gravity pulling me towards the moon will be different. So the weight that is displayed on the scales will be different, will be less. And if I go to a planet that's bigger, it'll have a much greater gravity, be a lot harder to move. So on the moon, have you ever seen that on the moon? When you walk on the moon, as I've done many times, you walk slowly because there's very little gravitational pull, and you can jump up and you come down more slowly. Whereas if you were on Jupiter, you'd be like, oh no, I'm stuck to the ground, I can't move. In fact, don't even know if we would actually be able to survive, because the way our bodies are made and all our organs and everything, they're meant to all stay in a particular place. So we might end up just flat on the ground and everything being pulled down. I don't know. I haven't actually investigated that. I've just thought of that. And I'm sure if you Google it, you'll find out lots of things about that, because that's one great thing. If you become a scientist, you get to discover things like that. You get to work those things out without ever having to go. You can do experiments and things to find out what happens. They build huge bits of equipment to increase the gravity and decrease the gravity. And then one other question: how much would the mass will be the same, it will still weigh, its mass will still be 500 grams if it's in space at 0 gravity. How much will it weigh with 0 gravity? Yeah, weightlessness. It's called weightlessness for a reason. It has no weight because there's no gravity, but it still has its own inherent mass, which we've defined our point 0 on planet Earth as 500 grams. Now, a different planet, on some far galaxy, far away, they would have a different gravity. So this, if they managed to get their hands on, if they managed some of our sweet corn, the same packet, it will weigh something different on their planet, and they might decide that that's their mass, because everything on their planet is determined by their own gravity. So their mass and our mass will be different, because their scientists have come up with the mass that's determined by their gravity on their planet. Had you ever thought of that? Right, now, what's the next thing? So that's the difference between mass and, here we go. Now the next activity is, here we go, 4. So what the activity for primary is to just find things and weigh them and estimate and set them out lightest to heaviest, as we just did, and then look at pictures, find pictures of things, just talk about the difference in, well, the mass of things, and then always be thinking which is the lightest, which is the heaviest, and then also whether or not you should be, for example, if I was giving the mass of this, would I be giving it in grams or kilograms? Would I be estimating it in grams or kilograms? And then we had the baby. Would we estimate the baby's weight in grams or kilograms? And if we have a car, would we estimate the car's weight in grams or kilograms, or something else? Okay, so here we go, here we go, here we go, here we go, here we go. And one, here we go. Right, here's the other one. So here's the question. The question is, what you want to estimate the approximate weight of a jug of water, a jug of 1 kilo of water. If you were listening, you'll know what that, I said 1 kilo of water, silly me. A jug of 1 liter of water, what does that weigh? A little spoon, or a little plastic spoon, or a little pen, a car, a minivan. Some people call it minivan. In South Africa, they're called taxis, and they're huge. They carry 12, 14 people, and people wait. They're basically buses. They were just small minivan buses, and they go to different places, and they call them taxis in South Africa. So one of those, a minivan or a taxi. And one thing I like is, what is the difference with when it's full of people and when it's empty? So an estimate of how much it weighs when it's empty and how much it weighs when it's full. So if there's 14 seats plus the driver, how much will that weigh? So you've got to think about how much the people weigh. How much is a cow? How much is a man, a woman, or a child? But let's say we'll just take a man for this one. And then what about a London bus? Ha ha ha. And then decide again whether or not you're going to be estimating it in grams, in milligrams, or in kilos, or in metric tons. Now, 1 metric ton is 1,000 kilograms. So we've got milligrams, then we've got grams. So a milligram is a thousandth of a gram. A gram is a thousandth of a kilo. A kilo and a ton. A kilo is a thousandth of a metric ton. A metric ton is, it's all calculated with respect to the kilo. So it's either more than a kilo or less than a kilo. And oh, right, and it says here, it does say here, 1 liter of water weighs 1 kilogram. Right, and then there's an activity as well, another activity to do on this, which is a recipe. So you can make soup for 8 people, and then you have to work out how to scale that up with all the different ingredients. And there's a lot of ingredients on here. Scale it up to make a soup for 120 people. So I think that's quite a fun activity to really, because you've got grams, you've got liters, you've got teaspoons, you've got quantity of food, you've got it's, yeah, just lots of different ingredients. So you had to create a recipe for 120 people. It would be interesting to actually test that recipe and see how it tastes. So those are the activities for primary. Now for secondary, for lower secondary, I have to get my chart out. So what I'd love you to do is, and you could do this in primary as well, is contact all your friends, everybody in your class, and find out how, upper secondary can do it, everybody can do it, find out how much everybody weighs. Now, ideally, for one activity, you want everyone that's more or less the same age, so everyone in your class or your age, so that you're comparing the weight of different people of the same age. And then another different one would be comparing the weight of different people's ages, and you'd record that in a very different way. So we're going to record the one where everybody is the same weight, and then you can also find out what everybody's weight is, maybe everybody in your home, everybody in your environment, the friends of the family, external environment, and find out all the different ages, and you've got to record the age and the weight. Then it's very important to record the age and the weight. Well, or you can just do it the other way, but you've got to think about how to actually make a graphic of it, a picture of it. So I'm going to get a picture here just to make sure we get something super clear. So let's say everybody in your environment weighs between 20 and 35 kilos. That's the ones that the people in your class. Now it might be for you, it might be 30 to 45 kilos, it might be 30 to 60 kilos. That's a lot. It depends what age you are. So, yeah, I mean, if you're 18, then people might be weighing between, if you've got a bunch of 18-year-olds, might be weighing between 40 and 80 kilos, depending, because it depends how much you've grown, if you've got any more to grow and things like that. Okay, so, but we're going to assume for this, we're going to go from 20 to 35 kilos. And what we want to do is we're going to start doing a bar chart and a pie chart. Okay, so you're going to create a pie chart and a bar chart. Now, what's important is that you're very, very clear about where everything goes. So you're going to have everything that's less than, let me get this straight, that's less than 20 kilos. Anybody that weighs less than 20 kilos. So that does not include people that weigh 20 kilos. That includes people that weigh up to 19.99 grams. Kilos. 19.99 kilos. If they weigh 20 kilos, then they come into this next bit. So if you weigh 20 kilos and if your mass, I'm going to write this out again. If your mass is greater than wait a minute. It's really important that I get this right. I've got to see how this is being determined to 30 to 25. So we're going to do it in sections of 5. I get this all clear before I come on. And then when I come on, then this is 25. It's greater than 25. So this is going to help me. So let's go with this one because I've got the start and the stop. So this is something that catches people up, and it's, as you can see, it's catching me up, not because I don't understand it, but because in the moment you can get yourself in a muddle. So, and I'm going to do the categories, and then we're going to see now, because for this, so this is your mass. So this doesn't vary no matter what planet you're on. Your mass is going to be the same, assuming you haven't gained weight on the journey or lost weight on the journey to a different planet. And that's assuming that the highest weight is less than or equal to 35. If you've got people with a greater weight, then you keep going. But because these charts, the bar chart and the pie chart, they have very set lines. They're not a curve. Then you must decide at what point you go from there to there. And it's not ambiguous. It's not a surprise. It's not, oh, I think we'll put that one there and that one there. It's very, very clearly defined. So if your mass is greater than 25 kilos, which means that 25 kilos is here. So if you have 25 kilos, it'll be on this line here. So it'll be, if that's the 20 to 25 kilo box, it'll be here. And so that means that it's greater than 20. So basically, if you're 20 or less, if your mass is equal to or less than 20, then you will go in here. If you weigh between, if you, let's say you weigh 25 kilos, you'll go in here. If you weigh 25 kilos, you don't go here because it's less than 25 kilos. You go here where there's the equal. It's less than or equal to 25. And then if you weigh 30 kilos, where are you going to go? 30 kilos, you're going to go in this line here. And if you weigh 35 kilos, you're not going to go here. So it's more than, if your mass is more than 35 kilos, you're going to go here, but not if you're 35 kilos, you are going to go here. It's that equal sign. That equal sign tells you that if you are exactly on the border, then you are included in that line because you've got the equal sign there. So 25 goes there, 30 goes there, and 35 goes there, and everything else is quite clear. So 30 doesn't go there, it's less than 30, 30 goes here. 25 doesn't go there, it goes here. And the reason why we do it that way is because otherwise, because we don't want to be writing, well, this is up to it works. If you say equal to, if you just put that equal to, then you know where it changes. So 25 goes there, 30 goes there, 35 goes there, and 20 is before, and anything above 35, so 35.1 will go above. Okay, so that, I just wanted to make that super clear. And then, woo, that's it, drop the tray. And I'm going to wipe that. Oh no, it's okay, I've cleared the back. So the other thing we're going to do is that, so you can draw a bar chart and a pie chart to see what the distribution is of your classmates or people that you're the same age. And then the other one you'll do is a leaf, a stem and leaf. So basically everybody that's within the 20 kilos will go here. So and then you just literally just put the number. So you've got the 20 there, and then I think you just put the 2 there, and the 3 there, and the 4 there. And then if you weigh 21 kilos, you go here. If you're less than 20 kilos, you might be 19 kilos, that goes there, and you just put the 9 on. And then 42 kilos, we've got 2 people that are 42 kilos, and we've got somebody that's 33, somebody that's 32 kilos, somebody that's, I'm not going to make that, somebody, I'm not going to start with 3, 32 kilos, somebody that's 38 kilos, 2 people that are 39 kilos, and that's what just to remind you what a leaf, stem and leaf diagram looks like. And then with those, you can find out the mean, the mode, and the median. So if you need help with that, do put a comment on, and we'll make another video just to cover how to find the mean, the mode, and the median if you don't remember how. But that is what stem and leaf, because I needed a reminder of what a stem and leaf chart diagram looked like. And that was it. And then you can sort them all to, so once you first of all you record all the amounts, and then you sort them in order of in the numbers. So actually I've automatically sorted them. Just because I wrote them down, but you won't. So I'm going to do that differently again. So if you have 2 people, maybe one that's 39, one that's 31, one that's 32, one that's 31 again, one that's 39, one that's 34. They come up, you write them out in the order they come in, and then you sort them in numerical order, and then you work. Then from there you move the numbers around to work out the mean. Then you write a long list of numbers to work out the mean, the median, and the mode. Right, now, and then finally, the easiest thing to present and the hardest thing, 40 minutes, my goodness. The easiest thing to present and the hardest, not the hardest thing to do, but the thing that you've got to do most work for is your older learners from the 16 to 18-year-olds is we want you to do a project. That project will be relating weight to mass. So you're looking at any science where you relate weight and mass. So the weight being with the effect of gravity and the mass being the fixed scientific, it's what the scales give if an item is weighed on planet Earth with our gravity, that is a fixed mass, and then the weight will depend on the gravitational pull. And so we've got some examples. You could look at space travel, gravity with space travel. You could look at health issues. You could look at atomic mass and why it's important, and then look at the mass and the law of conservation of energy. So those are ideas, and that is all the activities that we've got for you today, as though that's not enough, and that you don't have to do them all today. This is a resource that's on the Aiming High website, and these are things you can dip into and out of whenever you want to do something about mass and weight. And of course, as you get older, you can come back to the same resource and do an activity that's suitable for another age, or you can go back and do the same activity, but do it differently because you've learnt more about it and you understand the weights better and all the different, the kilos and the tons and the things. If you download the activity, you've got some of the answers on there, but don't look at the answers, do the estimates, and then you can see how, and you can Google it so much that you can get on Google to find out a lot of the questions and the estimates that we were asking you about. So please do, if you like the group, please tell other people about the group if you like these daily lives. And also all of these are going up on the Bubbly Maths YouTube channel, and that's the lives are going up on there. And the really important one is the Maths Toys YouTube channel, which we're working on them, the videos, that's blank, the videos from the Aiming High, all the activities on the Aiming High website, that you can go there and get ideas, and you can search if there's a particular subject you need to look at, you can search there for some really nice ideas of ways to gain understanding and insights into the maths that you have to learn in school. And so yes, please do tell everybody about this group. Please do subscribe to the YouTube channels, and then as we upload videos, those videos will really help you with working with these resources. And I'll see you at 10 o'clock. Whoa, 17 minutes till the next live for the early years. And then 8 o'clock tonight will be the preparation for tomorrow's 9 o'clock live, which won't be as long as this one, hopefully. This is a super long one. When I enjoy it a lot, I get carried away. I hope you enjoyed it as much as I did. I'm going to have a look, see if there's anybody made any questions outstanding. And there's no questions outstanding there. I didn't manage to figure out how to get onto the watch party today, so that seems to be the best way for people to get it. So I will end this live now. Thank you very much and see you tomorrow. Thank you. Bye.